Hello, assalamu alaikum, hello, bonjour. The question on section 2.2, number 38, is asking to find the limit as x approaches pi from the left of cotangent of x. What does the function of cotangent of x equal at pi from the left? So as the x values approach pi from the left, less than pi, what does the y value approach? This is another way of thinking about it. And so this is the graph of f of x equals cotangent of x, and we see as we approach pi from the left, so values, x values that are less than pi, what does the y value approach? And we can see that it's approaching negative infinity. It's very important that we've distinguished pi from the left. Had we said from the right, we would have got out positive infinity. And so now that we know what the answer is, we have to prove algebraically. Okay. When you have these type of questions, when you have limit questions when it comes to cotangent and tangent, it's important that you redefine them in terms of sine and cos. So cotangent is, of course, cos over sine. So we can write the limit as x approaches pi from the left of cos of x over sine of x. Now, I'm actually going to write two different limit statements. Of course, you can do it, you don't have to. I think it will be easier for you to understand if I do so. The limit as x approaches pi from the left of cos of x divided by the limit as x approaches pi from the left of sine of x. And so let's evaluate each limit statement individually. Cos of x at pi is -1. Now, it doesn't matter how we approach -1. The sign is what's important, really. And -1, approaching -1 through the negative values and positive values is not, it doesn't make a big difference. This is going to equal -1 nonetheless. So -1 on the top. And we can verify that through graph, through the unit circles. But I think by now you know that cos of pi equals -1. Okay. Sine of x, now this one's a little bit more different. This one, it's more important that we distinguish from the left and from the right. So this is the graph of f of x equals sine of x. This is sine of x. And, or is it good quality here? Okay, no, it's okay, keep it going. So, if we approach pi from the left, okay, we're approaching 0. We're approaching 0. We're never actually hitting the neutral number 0 because we're getting to numbers very close to it, okay, but we're never actually touching it. So as the x values approach pi, sine is going to equal 0 at pi, as we can tell. But it's nearing 0, it's tending to 0 through the positive values. And so we can denote that as Professor Turnbull says, 0 from the right, which of course he emphasizes its bad notation. And so what it means is really 0 but positive 0. So we're approaching 0 from the right. And another way you can think of it is really -1 divided by 0.0000, etc. Okay? But it's positive, and that's what's important. Now, -1 divided by 0 from the right is going to be negative infinity. So how do I know that? The limit as x approaches 0 from the right, okay, of a over x. If a is greater than 0, then this will equal, okay, if it's greater than 0, it will equal infinity, positive infinity. And a has to be any number greater than 0, any number. And now, if we took the same limit statement, and we said that if a is less than 0, a negative number, a negative a value, -5, -100, -10,000, it really does not matter, as long as it's not infinity, then it will be negative infinity. Okay? Of course, this is the case that we're working with up here. We have a negative a value divided by 0 from the right. Then we have, of course, negative infinity. And that's basically it.